We often hear about the Milky Ways, planets, stars, galaxies, and many such celestial bodies in the news every day. But have you ever think how the origin of the universe has been taken place? So, without wasting any kind of time, let's begin. The universe is everything, from the tiniest particle to the largest galaxies, to the very existence of space, time, and life. But how did it all begin? The origin of the universe is the origin of everything. The various scientific theories have tried to explain the mysterious genesis of the universe around the world. However, the most widely accepted theory is the Big Bang theory. This theory was born of the observation that other galaxies are moving away from our own at great speed in all directions, as if they had all been propelled by an ancient explosive force. A Belgian priest named Georges Lemaitre first suggested the Big Bang theory in the 1920s, when they theorized that the universe began from a single primordial atom. The idea received major boosts from Edwin Hubble's observation that galaxies are spreading away from us in all directions, as well as from the 1960s discovery of cosmic microwave radiation (CMR), interpreted as echoes of the Big Bang by Arno Penzias and Robert Wilson. Further work has helped clarify the Big Bang's tempo. Here's the theory: in the first 10 raised to the power minus 43 seconds of its existence, the universe was very compact, less than a million billion billionth the size of a single atom. It is thought at such an incomprehensibly dense, energetic state, the four fundamental forces, gravity, electromagnetism, and strong and weak nuclear force, were forged into a single force. But our current theories haven't yet figured out how a single unified force would work to pull this off. We don't need to know how gravity works on the subatomic scale, but we currently don't. It is also thought that the extremely close quarters allow the universe's very first particle to mix, mingle, and settle into roughly the same temperature. Then, in an unimaginably small fraction of a second, all that matter and energy expanded outward, more or less evenly, with tiny variation provided by fluctuations on the quantum scale. That model of breakneck explosion called inflation. Many explain why the universe has such an even temperature and distribution of matter. After inflation, the universe continues to expand, but at a much slower rate. It is still unclear what exactly powered inflation. So, before we are moving further, let's understand aftermath of cosmic inflation. As time passed and matter cooled, more diverse kinds of particles began to form, and they eventually condensed into the stars and galaxies of our past present universe. By the time the universe was a billionth of a second old, the universe had cooled down enough for the four fundamental forces to separate from one another. The universe's fundamental particle also formed. It was still so hot, though, that these particles had not yet assembled into many of the subatomic particles we have today, such as the proton. As the universe kept expanding, this piping hot primordial soup, called the quark gluon plasma, continued to cool. Some particle colliders, such as CERN's Large Hadron Colliders, are powerful enough to recreate the quark gluon plasma. Radiation in the early universe is so intense that colliding photons could form pairs of particles made of matter and antimatter, which is like regular matter in every way, except with the opposite electrical charge. It is toughest that the early universe contained equal amounts of matter and antimatter. But as the universe cooled, photons no longer packed enough punch to make matter-antimatter pairs. So, like an extreme games of musical chairs, many particles of matter and antimatter paired off and annihilated one another. Somehow, some excess matter survived, and it's now the stuff that people's planets and galaxies are made of. Our existence is a clear sign that the laws of nature treat matter and antimatter slightly differently. Researchers have experimentally observed this rule imbalance called CP violation in action. Physicists are still trying to figure out exactly how matter won out in the